Hi to everyone. MEM School of Engineering, Department of Mechanical Engineering, subject Mechatronics, online class 6, unit number 1, chapter number 6. Myself, Saranan, assistant professor in Mechatronics department. So, Mechatronics Engineering department, Mechatronics, course objective and outcomes. This is syllabus for Mechatronics, textbooks and reference, unit 1. Okay. So, this is chapter 6. So, today we are going to see about temperature sensors and light sensor. Okay. So, last class we discussed with different kind of sensors, all effect sensor, eddy current sensors, like that we discussed. Okay. So, in this chapter we have, this is the last chapter in the unit number 1. Okay. Finally, we have different type of temperature sensors and light sensor we are going to discuss. Okay. Let's see what is temperature sensor, like that. So, temperature sensor. So temperature conveys the state of mechanical system in terms of expansion. In terms of expansion or contractions of solids, liquids or gases, change in electrical resistance of conductors, semiconductors and thermoelectric EMFs. Okay. So these are the conditions. If we changes in the liquids, conductors, like that, we can calculate the temperature. So temperature sensors such as bimetallic strips, thermocouples, thermistors are widely used in monitoring of manufacturing process such as casting, molding, metal cutting, like that they are using. The construction details and principles of working of some of the temperature sensors are discussed in the following sections. So that is a common types of temperature sensor is bimetallic strips, resistant temperature detectors, then thermistors, then thermocouples. Okay, let's see bimetallic strip temperature sensor. So bimetallic strips are used as a thermal switch in controlling the temperature or heat in manufacturing process or system. Okay, it contains two different metal strips bonded together. Okay, the metal have different coefficients of expansion, and heating the strips bent into curved strip with the metal with a high coefficient of expansion on the outside of the curve. This is the example of bimetallic strip. This is this is a high expansivity material. This is low expansivity material. This is a soft iron. Set temperature adjustment. Okay, like that. Okay, so temperature adjustment will define the, so which temperature the metallic strip will be elastic, like that we can calculate. So this is the normal temperature. Bimetal strip will be like this. In elevated temperature, so bimetallic strip will be inclined like this. Okay. So this is the bimetallic strip thermostat. Okay, that means if this bimetallic is heated, so it will connected with the electrical connections. So the switch will be on or off, like that we can program. Okay, that is bimetallic strip temperature sensor. So next one is resistant temperature detector. Okay, that means when resistance comes, so sorry, when temperature comes, the resistance will be varied. That is the resistance temperature detector. Okay, RTD works on a principle that the electric resistance of a metal changes due to changes in its temperature. Okay, so the construction of resistor temperature detector RTD, it has a resistor element connected to a Wheatstone bridge. Connected to a Wheatstone bridge, the element and the connection leads are insulated and protected by shell. A small amount of current is continuously passing through the coil. As the temperature changes, the resistance of coil changes. As the temperature changes, the resistance of the coil changes, which we detect at the Wheatstone bridge. Okay, that means resistance changes detected by the Wheatstone bridge. The RTD, the format of RTD are used in the form of thin films. wire wounded or coil. So they are generally made of metals such as platinum, nickel copper alloys. So platinum wire held by a high temperature glass adhesive in a ceramic tube is used to measure the temperature in a metal furnace. Okay, this is a basic example of RTD. So this is the resistive trimming tools, resistive pattern, ceramic chip like base, then RTD element to lead wires. Okay, application of RTDs, that is used in the air conditioning and refrigeration servicing, food processing, stoves and grills, textile production, plastics product processing, petrochemical processing, microelectronics, air, gas and liquid temperature measurement in pipes and tanks. So exhaust gas temperature measurement like that using RTD. So thermistor temperature sensor. This is the another type of temperature sensor. So that is thermistor. Here also they are using some material. Okay, in temperature sensor, they are using linearly variable having with respect to the temperature changes. Okay, so in thermistors, the principle of decrease in the resistance with increase in the temperature. Okay, the material used in thermometers are generally a semiconductor material such as metal oxide, doped polycrystalline, ceramic contain, barium titanate, and other compounds they are using. So as the temperature of semiconductor material increases, the number of electrons able to move above increased, which result in more current in the material and reduced resistance. Okay. So thermistors are rugged and small in dimensions. They exhibit non-linear response characteristics. Okay, this is the example for thermistor. There is a glass coated bit, thermistor input, that is thermometer lead output. It is a different packages of thermistors. Application of thermistors to monitor the coolant temperature and oil temperature inside the engine, to monitor temperature of an incubator,